So of the few slides we have, let's go just through those quickly because I really want to show you and spend some time with the demo and the code. And by the way, all the code is going to be posted. All the code I'll be showing today is going to be posted on my GitHub account. But that information is at the end. So sadly, you're stuck with me for at least the next 30 minutes, unless you are watching the recording. OK, so let's take a look at the use case first. So what you see here right now, this is the system-wide information management, or the SWIM for short. Is a program part of the National Airspace System, or NAS, here in the United States. SWIM's goal it is to deliver the right information to the right people at the right time. This information sharing platform offers a single point of access, as you can see here, for aviation data, with producers of data here, publishing it once, and users accessing the information they need through that single connection. And well, as you can see, it has multiple data producers. And depending on what type of data you need, you subscribe to one or more of them. Most of these are public, that you can just apply to it, and they will give you access if you have a valid reason. But basically, this is a typical publish and subscribe architecture, as we can see here. Sorry, but in summary, SWIM provides access to aviation information through a single connection. And our goal here is to help data scientists ingest and analyze it easily. And today, I'm going to be using TFMS, which is Traffic Flow Management System, which gives you information about departures, delays, landing, among other things. So with that background, let's take a look at this possible architecture, which will allow us to consume this data and make sense of it. On the left side, we see all the data producers from SWIM. And on the right side, we have our proposed architecture in Azure. A couple of things to notice here is that we are using Kafka, which makes sense. Since this is a publish and subscribe architecture, and Kafka is really good at it. We have here, I can barely say it, but it is there. It is a SOLAS source connector. This is in order to connect and ingest the data from SWIM. SOLAS provides source and sink connectors that you can build and deploy in your Kafka cluster, which is really nice. On this end, we have an Azure Data Lake for storage. And at the end, we could have Power BI, Tableau, pretty much whatever you want to use in order to display the final information. But here in the middle, we also have Databricks. And this is to clean, prep, and parse all these messages that are coming from Kafka. Here is where data scientists are going to be doing most of their work, if not all of it. You know, they're going to write their notebooks in Python, Scala, R, you name it. They can write all the logic that they need in order to properly parse and analyze this data, or even train some models based on it. It's up to them. But before they get to this point to write the code they want and they need, there is a lot of work that needs to be done, right? All the underlying infrastructure, all the networking, all the configuration and integration across all these tools and services. So there is we have a problem and also an opportunity here to help them. But before starting, I think it is safe to say that the industry has come to this conclusion that infrastructure and configuration management as code is a good idea. But with this idea, there is also a learning curve and some challenges along the way. Most of the times, data scientists really don't know or just don't care how the underlying infrastructure works or is built, as long as it supports the work they are doing. And well, that means that somebody else would have to build that initial environment for them, or they will be forced to learn and create it by themselves. It doesn't matter which one. The first reaction to build it is to do it manually, using whatever portal the cloud provider has for you. But creating these complex environments manually leads to future problems. Initially, in my experience, it will take weeks or sometimes even months before you could get a properly configured and ready to use environment where you could ingest, analyze, and visualize information you want or need. As you know, it takes multiple iterations to get to that point. And again, in my experience, once the initial environment is created, nobody wants to touch it, right? And this is for fear of breaking it, especially if we're doing it manually and there is no information behind it or documentation. Because at the end of the day, you never know what install or configuration is going to go next and is going to cause the next big problem and break everything. And this is just one environment. What happens if this gets more complicated and you have to replicate it in multiple subscriptions or accounts? At the end of the day, the goal here is to reproduce these environments regardless of the stage in the development life cycle. You want that level of consistency. So you never heard that bugs in production are not able to reproduce in dev tests, for example. And let's not forget about efficiency. By nature, these complex environments are not cheap. They are expensive. They usually have multiple cloud resources involved in their architecture, clusters, VMs, and heavy VMs that are really expensive. That if left idle can easily cost you a lot, right? That's something that we need to take into account. So again, there is a big opportunity here to help data scientists do their work faster and apply some best practices along the way. So this is something I really want to show you, if everything works as expected. So before we jump into the demo, here are some conventions. I'm lazy. I hate typing because I make mistakes. So I'll be using these shortcuts along the way and throughout the demo. So let's go to my terminal. So, okay, let's start here. So I want to show multiple workflows and scenarios. But first, let's take a look at the project structure. So this, again, the code is going to be in GitHub, but I have some folders with some code here. But the three main ones are these ones: Ansible, Notebooks, and Terraform Azure. Ansible will have all the Ansible code in order to do all the post-provisioning configuration. In this case, it's going to take care of Kafka configuration and access to SIEM. Notebooks is just a simple Python script that is going to test the configuration or the communication between Kafka and Databricks. And lastly, we are going to have Terraform Azure. This could be any provider, but in this case, I'm using Azure. That has all the code that is going to be required to provision all these cloud resources. And I pre-staged some of those because, again, this is a complex environment, takes some time. So to save some time, I've just created most of it, but I really want to show a couple of integrations, cool integrations that I have for you. So if we go inside Terraform, we'll see that there are multiple files here that I'm going to be using. But let's do a Terraform apply right now just to see what's going to be deployed. And again, I already staged a couple of resources already. The resource group, VNet, a couple of things that are going to be there. And while this is, right now it is creating a Kafka server, while that is running, let's go through the code a little bit. So this is the main Terraform file. Here, as you can see, I'm using a remote backend, and I always recommend that. I know that the initial, in the initial phases, it is common to use a local state. I don't like that. Terraform Cloud has a pretty generous free tier, to be honest. And there is, I really encourage you to use it. Right now, as you can see, I'm setting up my the organization and the workspace I'm going to be using. I am also pinning the versions I'm going to be using throughout the code. I'm using the latest Terraform as of last night. Maybe I didn't check this morning. Maybe I should have, but I didn't. I'm also using, as you can see, the Databricks Provider and the latest Azure RM Provider. And as you can see here, the VM is already created. If you want to see the code there, I'm using two provisioners right now. I'm using the remote provisioner and the local provisioner. The remote provisioner just makes sure that the VM is up and running and ready to be communicated. And once it is there, it just executes the local provisioner in order to execute this Ansible playbook command that will connect to the VM and start deploying all the configuration that we need. And as you see here, it's already connected to it. It's going to install Apache Kafka. It's going to go through all the configurations that it is required in order to have a Kafka server up and running. And we could go through that. This is the main YAML file for that Ansible playbook. As you can see, it has a lot of requirements and configurations needs to be done. And all the users, groups, the Solus connector that needs to be deployed. Pretty much everything that we need in order to connect to these data sources and ingest the data. At the end, we should have a Kafka server ready to use and be able to connect it to a stream. And yeah, right now it's in the last part of the configuration. The other thing I wanted to show you while that is going is this variables file. Right now, as you can see, I'm just using HUS2, but this could be easily changed to something else, and you can replicate this environment in a different region if it's required. I usually use these tags here in order to tag everything that is created. This is mostly useful for billing purposes and inventory and ownership of these environments, right? So you know who to send the bill. So this is done. I dumped this information here in the console just for demo purposes, but in real life, you probably want to save it somewhere else. We could easily connect to it and see if it's working properly. Probably the first thing we can check if Kafka is really working there. As you can see, it's already up and running. It's supposed to create a topic for us in order to store all the messages we're gonna get from Swim, and that's also working, which is cool. And yeah, so it's good, it's fine. So we deployed a Kafka server, it's already deployed, it's connected, and it is working. That's nice. But this is the first scenario, right? This is the first workflow. This assumes I'm working alone, that I have no team. But most of the cases, that's not true. Most of the cases, I have a team behind me, and I want to share this code with them. I wanna distribute the workload, right? Maybe I'm working on the Kafka configuration, and somebody else is working on the Databricks configuration. So I want to be able to share this code with everyone, and I'll be able to review the changes, and I want to be able to, as the changes are done, I want to see those already executed and properly created in Azure or whatever cloud environment you have. So this is where GitHub comes into place. And not just GitHub, we're going to show also integration with GitHub Actions. So in order to simulate that, let's jump to the code. And let's say I want to, this is just using the Databricks Workspace as a provider. Now let's use the Databricks Provider. Maybe somebody else in my team is good at this, and he's going to be in charge of creating the cluster and everything that is required in Databricks in order to do this, to make this environment work. So let's see, we're going to, instead of running this locally, we're going to just push these changes to GitHub. We're going to commit, and we're going to push these changes to my GitHub repo. And let's show that too. Here is the GitHub repo. As you can see here, it already triggered a pipeline here with the commit we just did. And if you see here in the workflow, it is basically the same steps I did locally. I'm going to do a Terraform init, a Terraform plan. I'm going to do a validate, things like all those steps that I do manually now are in GitHub Actions, are automated every time somebody pushes something to the main branch. So this way, I have the benefits of distribute my workload, to share my code with my team, and be able to delegate some of these tasks to somebody else, or to review the code, right? Or if something happens, to revert those changes. As you can see here, it already connected to my Terraform Cloud account, and it has a plan already, and it says that the only thing I'm doing is just creating a cluster in Databricks. Right? This is going to go and apply it. And while it does, we can check the portal here and see if all the resources are here. And if we go to the Databricks workspace that we created and we launch it, we should see that Databricks cluster coming up. So let's wait a little bit. And since I'm using Azure and this Databricks workspace is being deployed there with VNet injection, it authenticates me automatically. So it's nice. So if we go to the cluster section, as you can see, that's the cluster we just provisioned. And if we look at the code for that, as you can see here, I'm just getting the smallest VM just to save some money. I'm getting the latest Spark version, and here I'm just creating that cluster. As you can see, I'm using those variables from here. I'm using a termination, a timeout, basically. If in 25 minutes the cluster is idle, it's going to terminate it, right? That means nobody's using it. I'm doing some just minimal auto scaling in case we need more CPU power. I'm just a max 2, but this could be easily changed and applied, right? And if you see here, those configurations are being reflected here, right? The same configurations we did in Terraform using the Databricks Provider are here. At the same timeout, the set min and max workers, and I'm using the smallest VM that it provides, which is basically just a 8 gig memory and 4-core CPU. And this could be also extended. You can add libraries to this specific cluster that you need, right? That is just a change in the code, and you can just apply it. So if you see here, this is still going. While this is going, I want to show you the next. It is the pipeline itself in GitHub Actions. And again, this is another YAML file that lives in the repo that automates all these tasks. As you see here, my secrets, I have some secrets here. For Azure, you need the subscription, the client ID, the client secret, and the tenant ID they're going to be using. Those are set in GitHub Actions itself as secrets. I'm not passing anything in my code for security purposes. As you see here, I'm using the Terraform GitHub Action from the marketplace that takes care of pretty much everything that needs to be automated. The Terraform init, the validate, the format, basically the same steps I was doing are declared here. And here is this a cool thing that I like to add. This is in case you want to follow the GitHub flow, right? That in order to make changes, you need to submit a pull request, a PR. So what this thing does is that whoever submits the PR is going to save the plan in the PR as a comment. So the reviewer can see the plan and either approve it or deny it or make some comments or improvements, things like that. But before you approve it, you can see the plan in the PR as a comment, and then you can move on. And finally, it's gonna apply the change, right? The cluster is still working. It should come up running really soon. But the third workflow I wanted to show you, this is cool. This is nice. I have my GitHub repo. I have my GitHub Actions that's going to automate everything. But what happens if I'm new to the team, right? Or maybe I'm that data scientist that want to help and want to learn. How long is it going to take for me to install all these dev tools in my laptop? Maybe I don't have admin rights, right? But thanks to GitHub, again, they have this cool thing and that are code spaces, and which allows you to open this repo in a remote development environment. Here I have one I'm going to be using for the last part of the demo, which is basically my development environment in the cloud. all the tools I need are already pre-configured there, and I just need to use it as if I were in my laptop in order to make the changes I need and just push them to the repo. So right now it is connecting. Let's see. And as you can see, it's just basically a Visual Studio Code in the cloud. All the files that I need are here. The exact same files I have in my laptop. And if you see here, even my shell is the same, right? Because GitHub Code Spaces allows you to customize it using your own files. If you have them in your GitHub repo, it will grab those and will just customize your environment using those. So basically, all my shortcuts, the skins, and everything I have are here. So let's get the latest part of the code. And let's say right now, the last thing I want to do is just I want a notebook with some Python code that I want to use in order to test the connectivity. Right, so this is it. I can do a git status. I can stage these changes. All right, I can do a commit. And let me push this to my master branch. And while we were doing that, this other one already finished. So we should see the cluster here up and running. As you see here, it's already running. But because we pushed a change through GitHub Action to GitHub Code Spaces, there is another event trigger, right? So right now, it's just, again, it's going to get the code, it's going to do an init, a validate, pretty much the same workflow. But this change when it's doing, in this case, when it's doing the plan, you will see that it will detect that there is only just one change, and basically it's just adding that Databricks notebook to my cluster, right? As you can see here, that's the notebook, and it's going to apply it. And if you want to see that, we can go back to our code space, notebooks. This is basically the file we're going to be deploying in the notebook, right? So pretty cool. So if we go here, it is pretty much almost done. And if we go to the cluster and we go to workspaces, under share, we should see that the exact same notebook that we created. So the last thing we need to do is I just need to attach this to my cluster. Let's see if it really connects to Kafka, right? Cool. So Databricks is connected to Kafka. Now here, let's say the last 100 messages that are coming from that data source. So let's see. This is running. You can get all the details of this job here as it moves along, right? So here it is. It finished. Swim uses heavy XML schema, so you're going to need a lot of Spark XML in order to parse it. But as you can see here, my Databricks cluster is already connected to Kafka, and I'm able to stream all these messages, right? So that's pretty cool. So at this point, well, this is the point where we could hand over this environment to the data scientists or whoever is going to be working on it, and let them write all the code they need, right? Basically, everything is done. They just need to write the code that they are supposed to write. So we went from pretty much nothing to a workable environment in like 15 to 25 minutes, and I think that's pretty acceptable. And going back to slides, putting all together, we basically saw this flow where everything starts with developers. Developers have this crazy idea of version control and being able to see the changes that were made for a particular file or directory, not just what changes, just also who and when those changes were made. It is easier now to distribute the work and to collaborate. And the benefits that gives when you have your infrastructure and configuration as code are that you are not just able to say what is currently being deployed, but being able to repeat it and to say how it was deployed a week, a month, or even a year ago, which is pretty cool. And again, since everything is code, you can easily apply development lifecycle principles, and of course, create CI/CD pipelines, as we saw before. Just to wrap it up, here are some snippets that I really want to highlight. Specific parts of the code that we saw. Here is where we are. We're using Terraform Cloud again, and we specify the provider we're going to use, in this case, Databricks and Azure. And we could be using multiple providers for that matter. Here, we can see how we integrate Terraform and Ansible to do all the post-provisioning tasks. And this could be Chef or Puppet or some other configuration management tool, right? Terraform makes it really easy to integrate them, and that's awesome. Finally, here we see how we used the Databricks Workspace resource from the Azure provider. And once the cluster, the workspace was done, we used the Databricks Provider in order to connect to it. The Databricks Provider has multiple ways to authenticate, but using these in Azure makes it really easy. Basically, it uses the credentials you already have in order to use the Azure provider and reuse those in order to authenticate Databricks. And with that, you can create Databricks specific resources like the cluster we saw, or the notebook, or libraries, or secrets, pretty much everything. It's really cool. Sorry. So finally, some key takeaways. I think it is fair to say that automation is key here. It allows us to easily deploy these complex environments, and since everything is code, we could replicate it basically anywhere. We could even create disposable environments for quick testing and research, you name it. And if successful, we can integrate those in our production or main environment, which is basically just a PR away, a pull request. We also get built-in documentation for faster onboarding if I'm new to the team. On the tooling part, I know DevOps is not about tooling, but tooling is so much fun sometimes when it works, at least for me. It is amazing the things you can achieve when you integrate all these tools together. Thanks to GitHub, and you have version control now, so you can review the historical changes and revert them back if it's needed. And if I'm new to the team, as I show it, all you need is access to GitHub, and I can have my complete development environment there in a code space. It's ready for me to start working. No need to wait for somebody else to get me admin rights in my laptop to install the tools I need. So that's pretty nice and pretty cool and powerful at the same time. So with that, I think that's pretty much everything I want to show you. I just want to say thank you. Hope you enjoyed the presentation. Let's keep in touch. Here is my contact information if you have any questions. All the code I show today is going to be available in my GitHub account, as promised. Thanks to HashiCorp for the opportunity, and Nick, Dominic, Tracy, and Katie, basically the whole HashiCorp team to make this possible. And I think I don't know if I have time for questions.
You do, which I actually have one.
Awesome.
It's an easy one though, I promise. First off, thank you for doing this particular one. I haven't been using Code Spaces as much as I probably should, and there's a talk that I want to come up with. So you just reminded me that I could actually use that integration with GitHub Actions, and it might work a little bit more seamlessly than I previously imagined. That said, how did you get into data analytics, or like what made you decide to become a data scientist?
Well, I'm not really, to be honest, because I'm going to get to it. The thing that got me into it is because I'm helping data scientists build these environments, right? So to better serve them and to properly build them and efficiently, I need to learn, right? How the Python code that they have is used, what kind of requirements are needed, how they connect to these resources that right now I only showed one, but most of the times there are multiple resources I need to connect to. Right. So since I'm helping them build these environments, I'm forced to learn how they work. So I'm getting into it.